Welcome to Kerala, India's coconut heartland, where millions of liters of wastewater transform into luxury vegan leather.
Kerala, meaning land of coconuts, produces over 6 billion coconuts annually, supporting thousands of families.
Traditional coconut processing creates valuable products, but generates 4,000 liters of wastewater daily per unit.
This discarded water causes soil acidity and water pollution when released untreated into drainage systems.
Founded in 2017 by Zuzana Gombosova and Susmit C., Malai transforms this waste into sustainable material.
Malai partners with 15 local coconut processing facilities across South India, collecting their wastewater.
Each day, thousands of liters travel to Malai's Fort Kochi facility for transformation.
Fresh wastewater undergoes testing for glucose, fructose, and mineral content, ensuring optimal fermentation conditions. Initial filtration removes coconut fiber fragments and impurities through micromesh screening systems.
Filtered water retains natural sugars, amino acids, and minerals, perfect for bacterial growth.
20-minute autoclave cycles create sterile medium, maintaining coconut water's nutritional profile.
pH adjustment to 4.5 creates ideal acidic environment for Comagotibacter bacterial culture.
Supplementation with acetic acid and specific amino acids increases bacterial cellulose yield by 165%.
Sterile medium fills shallow fermentation trays, maximizing surface area for bacterial cellulose formation.
Controlled temperature at 30 degrees Celsius and 70% humidity create optimal bacterial growth conditions.
Comagotibacter bacteria, previously called acetobacters, naturally produce cellulose as protective biofilm.
Mother culture maintains bacterial strains optimized over hundreds of trials for maximum cellulose production. Precise inoculation introduces bacteria at controlled density, ensuring uniform cellulose sheet formation. Fermentation occurs under static conditions, allowing bacteria to form continuous cellulose pellicle at the surface. Within 72 hours, bacterial colonies multiply, rapidly secreting nano-sized cellulose fibers at water-air interface. By day 5, the cellulose membrane reaches 3 millimeters thickness, with billions of interwoven nanofibers.
Each bacterium produces cellulose nanofibers, 20 to 50 nanometers in diameter, creating incredibly strong mesh.
After 9 days, bacterial cellulose reaches optimal thickness of 6 to 8 millimeters, ready for harvesting.
Continuous monitoring tracks fermentation parameters, ensuring consistent quality across all production batches. Fermentation time directly affects thickness and mechanical properties of final material. Harvesting requires gentle handling as fresh bacterial cellulose contains 99% water by weight. The gelatinous sheet resembles thick nata de coco, translucent with remarkable strength and flexibility.
Each fermentation batch yields 25 to 30 sheets, representing 200 square meters of potential material monthly.
Extensive washing removes residual bacteria, acids, and fermentation byproducts through 10 rinse cycles. Each wash cycle takes 30 minutes, gradually purifying cellulose while maintaining structural integrity.
Final washing achieves pH 7.0, eliminating all acidic residues, ensuring skin-safe final product.
Pure bacterial cellulose appears snow-white, odorless, and remarkably uniform in thickness. Natural plant fibers from banana stems, hemp, and sisal provide reinforcement and unique texture variations.
Banana stem waste from agriculture provides strong cellulose fibers, continuing the circular economy approach.
Hemp and sisal contribute durability and distinctive texture, creating Malai's signature feel and appearance.
Wet bacterial cellulose acts as natural binder, incorporating plant fibers into three-dimensional matrix. Nanofiber structure creates mechanical interlocking with plant fibers, forming strong composite biomaterial. Plant-based gums from acacia and guar improve fiber adhesion without compromising biodegradability. Hydraulic pressing extracts water under 10 bar pressure, reducing moisture content from 99% to 85%. Pressing aligns fibers and compact structure, beginning materials transformation toward leather-like properties.
Gentle drying preserves cellulose nanofiber network, responsible for material's exceptional strength.
Target moisture content of 8 to 12% provides optimal balance between flexibility and dimensional stability. As moisture evaporates, material develops characteristic leather feel while remaining completely plant-based.
Eco-friendly dyes from turmeric, indigo, beetroot, and other plants create a vibrant color palette.
From earth tones to vibrant hues, natural dyeing offers 30 standard colors without synthetic chemicals.
Cold dyeing at 30 degrees Celsius allows gradual absorption, creating even coloration throughout material thickness.
Gentle rinsing stabilizes dye molecules within cellulose structure without color loss. Alum and other natural mordants bond dyes chemically, achieving light fastness comparable to synthetic textiles.
Color-coded drying prevents cross-contamination while maintaining Kerala's vibrant aesthetic traditions.
Coconut oil, castor oil, and natural waxes provide water resistance while maintaining breathability.
Hand application ensures even coverage, enhancing material softness and creating subtle sheen.
Natural treatment achieves water contact angle of 110 degrees, providing practical weather resistance.
Final pressing at 80 degrees Celsius under controlled pressure consolidates all layers into unified material.
Heat activation bonds natural oils with cellulose, creating supple texture rivaling animal leather.
Heated embossing rollers create diverse surface textures, from smooth nappa to textured grain patterns. Embossing at 100 degrees Celsius permanently reshapes surface while maintaining internal structure integrity.
Pattern options include classic leather grain, linen texture, and smooth minimalist finishes for different applications.
CO2 laser cutting creates clean edges and intricate patterns without fraying or material damage. Precision measurement ensures consistent 1.0 to 1.5 millimeter thickness throughout each production batch.
Tensile testing measures breaking strength exceeding 600 newtons per 5 centimeters, surpassing many synthetics.
Material flexes through 180-degree bends over 10,000 cycles without cracking or delamination.
Martindale testing shows 50,000 cycle durability, suitable for accessories and light footwear applications.
30-minute water immersion test confirms surface protection while maintaining breathability for comfort.
Accelerated UV testing simulates 2 years of sunlight exposure, confirming natural dye permanence.
Home compost testing documents complete biodegradation within 90-150 days, leaving no toxic residue.
Dermatological testing confirms 0 allergens, meeting international safety standards for direct skin contact.
PETA certification verifies complete supply chain free from animal products or animal testing.
Master inspectors examine every square meter for uniformity, defects, and adherence to specifications.
Grading system ensures appropriate material application, from luxury fashion to eco-friendly packaging.
Standard sheets measure 30 by 40 centimeters, optimal for accessory production and design sampling. Rolled storage prevents creasing while maintaining material properties during distribution to designers.
Each batch receives unique identification, ensuring complete traceability from coconut source to final product.
International designers from 15 countries incorporate Malai into sustainable fashion collections.
Local Kerala artisans handcraft accessories, combining traditional techniques with innovative biomaterial.
Product range includes fashion accessories, footwear, and interior design applications, showcasing material versatility.
Visual and tactile properties match premium leather while offering superior environmental credentials.
Production uses 90% less water than traditional leather tanning, preventing 4,000 liters daily from pollution.
Carbon footprint reduces by 85% compared to animal leather, supporting climate-positive manufacturing.
Transforming agricultural waste into valuable material prevents methane emissions from coconut water decomposition. Farmers earn additional income selling previously worthless waste, strengthening rural Kerala economy.
Malai employs 25 local workers, providing skilled manufacturing jobs in a sustainable industry sector.
Winner of 2020 Circular Design Challenge at Lakme Fashion Week, recognizing innovation excellence.
Featured in London Design Week, Prague Design Week, and Mumbai Fashion Week, showcasing global appeal.
Academic partnerships advance material science research, exploring enhanced properties and new applications.
Malai Pure variant achieves thinner profile and smoother finish for apparel applications, expanding market reach.
Research explores applications in furniture, automotive, and medical sectors, leveraging material biocompatibility.
Unlike synthetic alternatives, Malai returns to Earth naturally, closing the circular material loop.
Complete biodegradation leaves only organic matter, unlike petroleum-based leather alternatives requiring centuries.
Designers praise Malai's workability, designers praise Malai's aesthetic appeal, and consumers value sustainable authenticity.
From Kerala's innovation hub to global markets, Malai reaches conscious consumers across 4 continents.
Educational initiatives inspire next generation of material scientists and sustainable fashion designers.
Our vision proves waste becomes treasure when innovation meets traditional knowledge and environmental responsibility. Each partnership converts pollution into profit, transforming India's coconut industry sustainability practices.
Preserving traditional craftsmanship while embracing innovation creates meaningful employment and cultural continuity.
Malai joins global biomaterial revolution, each material offering unique properties from regional agricultural waste.
Academic publications advance bacterial cellulose science, contributing to global sustainable materials knowledge base.
Collaborations with established brands accelerate market adoption, proving viability of sustainable alternatives.
Social media amplifies Malai's story, inspiring consumers to choose sustainable materials over conventional options.
Government recognition of biomaterial innovation provides policy support, accelerating sustainable manufacturing sector growth.
Impact investors recognize Malai's dual benefit model, creating environmental and economic value simultaneously.
Malai Factory tours attract sustainable tourism, showcasing Kerala's leadership in green innovation.
Annual production prevents 50 tons of CO2 emissions, equivalent to planting 2,500 trees.
Diverting coconut waste protects coastal waters from acidification, preserving Kerala's marine ecosystems.
From coconut grove to compost bin, Malai exemplifies circular economy principles in material production.
Competitive pricing makes sustainable choice accessible, proving ethics and economics can align successfully.
Growing consumer demand for verified sustainable materials drives industry transformation toward circular systems.
Model replicability offers scalable solution for regions with agricultural waste seeking value-added transformation.
Global Biomaterial Network shares knowledge, accelerating collective progress towards sustainable material future.
From discarded coconut water to luxury fashion material in 14 days of bacterial transformation.